All right. And welcome everybody to this morning session or night session to MakeCode Live. We're going to be talking about something called Jacdac. You're going to hear that word a lot. Um, my name is Peli de Halleux, kind of a difficult name to pronounce. And I work for Microsoft Research. I've been involved with the MakeCode for quite a while from the start. And, our team built the original iteration of MakeCode, which is now maintained by the product team, the MakeCode team doing a great job there, and we've been kind of trying to figure out whether we could improve uh, the experience for teachers and students. Um, so what we're going to talk today about is something called plug and play accessories. This is something we've been working on for a few years now. And today we're kind of ready to unveil it and push it out. We've open source. We've been working on open source, and we have now the software, the firmware, the hardware out there. So if you're a teacher, this is going to be interesting for you. If you're accessory vendor, maker, manufacturer, this is also going to be interesting for you because this is something that's coming up your way. So without further ado, we're going to talk a little bit about why we built Jacdac and what's the deal with it. I mean, we got the microbit. Microbit is cool, but why do we need something else? Why do we need plug and play accessories? Well, I think why do we think we need it? All right, so with the microbit, we did a lot of work making electronics accessible, and everybody, it's a big success. If you look at this conference, you can see really it allowed kids and teachers who would not be doing embedded programming to go and do stuff. Now, one thing we've noticed over the time is that the accessory story could be improved. So we have a great ecosystem of accessories for the microbit. If you go to the accessory page, you see there's dozens of them, but they're not always consistent. In fact, some things could be improved. Some of the problems we heard from educators when we start talking to the users was it's sometimes difficult to figure out where the code is for a particular piece of hardware you purchased. So the students don't, obviously they get lost or they load the wrong library or so forth. So that's a problem you see in the classroom, and any problem in the classroom gets amplified by the number of students. The other problem we saw was that the block terminology, the way the blocks work, the assumptions about the block was not consistent across multiple vendors. And the reason is, it's multiple teams, multiple companies with different kind of habits building these extensions. But that creates problems in the classroom because you build this expectation on how blocks work. Now they don't always work the same way. A big issue with third-party accessories, and this is something I worked on for a while and we really tried to fix, is that it's really hard to bring first-class simulator support for every accessory out there. In MakeCode, we have NeoPixel support, and we have a few of those, like servos were popular, but there's a ton of other accessories we just don't have simulator support for. And that means you don't have this great tight feedback loop when you're coding, and it makes the experience much less easy. And also, if you don't have the hardware, then you can't even try your code. So lack of simulated support has always been something that was bothering me, and there's so much different ways to talk to hardware out there that it's not feasible to just add more and more simulators. And on the other hand, we just can't import random code from internet that people wrote because this would be really bad security-wise. So we were stuck in a way where we had some support for, kind of the major accessories, but for many accessories out there, you don't have limited support. And that's something that Jacdac is going to solve for you. The other thing that we noticed is that, electronic cables were designed for electronic engineers, not for classrooms full of kids who want to rip out the cables or chew on them or, whatnot, or stuff them. So we we tried to use, historically in Jacdac, we tried to use the good old audio jack, the 3.5 mil audio jack. It turned out that there were a lot of electrical issues with that. So we decided to create a new connector and a new cable that not only is friendly to students, but also friendly to manufacturer, because it is very cheap to add to your site. So this is the background on why we built Jacdac. And now what I'm going to show you is what Jacdac does for you. And let's start with MakeCode. Now, Jacdac is a general purpose protocol to talk to hardware. It can work with MakeCode. It also works with TypeScript, JavaScript, Python, any other software. So what you're going to see is a lot of MakeCode today, but it is not limited to that. So if you buy Jacdac hardware, it'll work with many other environments. What we built is a school-friendly cable and connector. I'm going to show you that. We have a integration in MakeCode that is in beta stage right now, and we're definitely looking for feedback on how it works. We will auto-detect hardware, load the blocks for you, and also we provide full simulator support inside of MakeCode. Now, without further ado, we're going to go for just a very long demo time. So that's kind of the fun part. I'm going to show you the hardware. I'm going to show you what we call the Jacdac dashboard, which allows you to kind of see what's going on in Jacdac. We're going to show you MakeCode, and then also, just for kicks, we're going to do a P5.js integration. If you're familiar with processing, this kind of creative coding environment, P5.js is the online JavaScript version of that. And we're going to see how we can use Jacdac in there. All right, let's switch to demo time. I'm going to bring out my my hardware cam, swap this. All right, so this is live, and this is actual hardware prototypes that we have for Jacdac. Your question is, can I get that too? Currently, there is no Jacdac hardware on sale. However, we've released all the schematics today, and we will be talking to accessory vendors. I have some slides for the accessory vendors, so stick around to get Jacdac into the ecosystem. So what do we have? We have a Microbit V2. Jacdac only works on the V2. Unfortunately, we couldn't get it to work on the V1. We have this cute little thing called the Jacdapter. Now, if you look at that, you'll see it has these teeth. You know, these teeth here. This is the Jacdac connector. It is built straight onto the electronic board. We call that a PCB edge connector. And, you know, it's meant to be very cheap. And now the new things we have is these beautiful cables. These cables they're made for classroom. They're made to be, so what do they have? They have reversible connection, because this is the iPhone generation. You know, you don't want to figure out whether it's one way or the other. Just plug it in, it works. They're made to be brutalized. You can pull them out, or you can just, wank them out. You can do that a few thousand times before they'll wear out. So this is really good for classrooms, because, as we know, students not always are the most gentle with our electronic. Can pull them out. The other thing that's happening with Jacdac is it is a bus, meaning you can just connect it wherever you want, just like USB. If there's a slot open, just put your device. It doesn't matter. It doesn't matter where you put it, because then everything works. And also that means you can daisy chain stuff. So if you bring a slider here, well, the slider exposes a second. My autofocus is really struggling. A second one, and you could just daisy chain the next one and keep going like that. Jacdac provides power. You don't have to worry about power as well. All right, so what we're going to do here is we're going to play with the Microbit. So the Microbit has a little app that we call it's called the out-of-the-box experience, because there's a kit. So I'm going to plug that in. And now I'm going to plug a button. So here's a button. Oh, here's my button. Here it is, hiding. So we have a keycap Cherry MX button. You can see it has here the little connector here. So I'm going to plug it in with my cable. And here I'm going to plug it in randomly in the middle. I'm trying to do that. Here we go. And you could see that the microbit told us, yes, there is one device connected. And in fact, if I press on the button, I get a sound and an emoji. That's how we program our little app here. So I'm going to bring a second button, but it doesn't look the same at all. This button is just more of a, it's not so much of a keycap, but it is still a button. That means it behaves like a button. You can click it, you can have a down event, an up event. Oh, let me get some cables. All right, so let's plug this in and randomly somewhere. And now the microbit says, yeah, you have two buttons. So if I click the second one, you can see that I have a smiley. And if I click the first one, you can see that I have another device. So how is that working? Jacdac devices will advertise themselves and will tell us, oh, I'm a button and this is my name. And so we can kind of detect that and handle that. And also, if you swap a button for another, let's say you lost that button, but somebody else sells another button, you can just use it. So if it's a button, it's like if it's a duck and behaves like a duck, if it behaves like a duck, it's probably a duck. So if it's a button, you can interchange them and so forth. And for example, we have one more prototype of a button here. This one has two, you can screw cables in, and let's say you can build like a button out of a button you go buy at your hardware shop. All right, so this is a fun one. If I put a slider, for example, let's bring our slider here. See that now, if I'm moving my slider, we've actually programmed it to change the LEDs on the thing. And again, this is dynamic. That means if I unplug it, eventually, I lost the device. If I plug in something like, so I have here a plant, and in that plant I have this one. I have a soil moisture sensor, and I have a temperature sensor probe here. The temperature probe goes to a Jacdac module here, and I'm going to connect that into my Jacdapter. All right, let's go back here. Let's plug it in. And I'm using that super cool font that lets you show two numbers on the Jacdac screen. So what you're seeing is it is 19 degrees Celsius in my plant right now. I don't know if that's good or bad. I'll assume that's good. I need to return. I've used that plant for demos. I need to return it alive. So that's a temperature sensor, and then we get rich data. We know what the temperature is and so forth. Now let's take a look at what Jacdac looks like when you're actually playing with that. And what I'm going to do is I'm going to go to the Jacdac website before I go to MakeCode. And this is a website. This is aka.ms/Jacdac, and this is what we call our dashboard. And what I'm going to do is I'm going to connect to the microbit. I'm going to click on connect. And what you see now is that I have a view on the hardware. So this button here is one of those two. In fact, if I want to know which one it is, I can click on the name here, and it's going to start blinking. One of them is going to start blinking. Oh, you see the blue blink here? Let's see. So that's an identify thing. So it says, oh yeah, that's me. It's me on the screen. In fact, it looks like the picture, so that helps. Close, thank you. And this is a twin of the hardware. If I press the button, you see press the button, and I see it on the hardware. So this allows me to see, I mean, it's obvious that I'm pressing the button, so that's great. But if you look at the temperature, now I can see that it's 19 degrees. I could also, chart the data to see if things are changing. So if I plug in now I'm going to plug in my soil moisture sensor, and immediately we get the soil moisture sensor. In fact, if I'm pulling it out from my hardware and moving it around, or you can see that the reading changes. and it changes live. And we read it live here, but also we see it live on the screen. And this dashboard, we built this dashboard for a reason, because this is going to be the building block for the experience inside of MakeCode. We're going to use this particular dashboard with a bit less of UI elements as a way to show the state of the hardware. And these are basically our simulators. Now, one thing that's very important is that, let's say I don't have a soil moisture sensor. So let me say I'm going to unplug that thing. And Jacdac is going to detect that the device is gone. What I can do is I can start a simulator. I can start a virtual soil moisture sensor. So we've got some shortcuts here. So, I can click on the shortcut, but if you want to select one of those, we've got a bunch of these around. So this is a virtual soil moisture sensor. It only exists in your browser. But if it's virtual, that means you can actually change the value. So you get a little slider, and you can go. And this is great for testing, because if you're testing code that's supposed to run in a fridge, you don't want to be in the fridge. If you're testing code where it's raining or there's too much water, you can't do that with your plant. You would have to. So this is very helpful, and of course in the classroom where you don't have enough hardware, this is essential to have simulators. So you're going to see that this is going to fit straight into your MakeCode experience. And of course, you get all the charting and so forth in here. You can spin up as many simulators as we want. There's some really fun ones. You can simulate, kind of gas detection and so forth. So this is all running in the browser. And this is using WebUSB, so there's nothing to install. It just works straight off the bat. All right, let's switch to MakeCode, shall we? And show how this experience fits in MakeCode. Oh, one thing I forgot to mention is that this is prototype hardware. We also have ideas about 3D printed enclosures. So we have little helpers that generate those, and then you can print that, and then you get it protected. But this hardware is not available, but the schematics are available for people who sell accessories. Let's go to MakeCode. So this was a dashboard. This is a separate website from MakeCode. It's kind of more of a neutral way to kind of play around with the hardware of Jacdac. There's a few features in there like data collection and so forth, but we'll not cover that today. All right, switching to MakeCode. And here we are in the beautiful MakeCode from Microbit. I'm going to create a new project, which is Microbit Live, Jacdac. And there's a question whether this is available or not. And the answer is, it is available. So all the software is online. And in fact, you can use whatever I'm demoing today. As far as the simulators, this is all online. You can try it out. However, the hardware is not on sale yet, because we just open sourced our schematics today. And hopefully we'll be working with accessory vendors to integrate that into their product. If you're an accessory vendor, stick around. I will talk about what you can do. All right, so I'm in MakeCode as usual. What I'm going to do is, to start the Jacdac experience, is to add an extension. Our beautiful extension here, and I'm going to type Jacdac. Press enter, and you'll see that there's one match. This is our library, and this is the only library you need to add through the UI. The rest is going to be automated. We add a new category called modules. We didn't want to call it Jacdac because typically it's hardware modules. And when you look at this, there's not a lot of interesting blocks, because there's so many accessories out there. We don't want to preload the blocks. We only want to load the blocks that you need. So based on what you're trying to do, based on what you're connecting, we're gonna need that. I'm gonna go back to this website and disconnect. Yeah, okay, I'm disconnected. Let's start with an experience with hardware. So there's gonna be two experiences I want to show. the experience where you have hardware. And in this case, what I'm going to do is I'm going to unplug everything and just keep a cool device called a rotary encoder. All right, rotary encoder here attached. I'm gonna secure this one. There we go. So that they don't move around too much. All right, rotary encoder is in place. And what I'm gonna do is I'm gonna connect the microbit through MakeCode. Connect device, next, connect. Done. And what you're gonna see now is that we are seeing our hardware device here in MakeCode. And just like we were seeing in the dashboard, I can change the hardware and I can see visually that I'm doing something with the hardware. All right, so what I'm seeing too is this button here that says, hey, do you want some blocks? Which is great because ka-ching, ka-ching, I don't have to figure out which blocks I need to do. I just click the button. I say, yes, I want all the blocks for my hardware that's connected to my system right now. So I only get the blocks I need, not every possible block that's out there. And now what you can see is that I got my button blocks and my slider blocks. Interesting. Oh, I put rotary encoder under a slider. Yeah, maybe that's dubious. But this is the rotary encoder, and then this is the button. So if I grab my button block and I decide to show something here like a heart, we're going to start with something like this. And when you press down, you get heart. And when you press up, you get something else. Just a quick example. Something like that. All right, so MakeCode restarts. I'm going to press the hardware button here. And you can see that we get the heart and then no heart. So what's happening here is, now how does this work? We got hardware button here and we got simulator support. Now, the hardware is doing something weird, is scrolling some text. So this is what we call dongle mode. Dongle mode. The physical microbit does not run your code right now. What it does, it just transfers the data into, let's see if I can do that. All right, so whoop, and then goes into the simulator. Okay, that was hard. All right, so this is in dongle mode, which means you're actually running, because you can only have one brain, and you can only have either the simulator or the physical microbit running your code, not the two of them, or they're going to fight. So right now the simulator is running, and the microbit is in dongle mode. Now, if I download, I'm going to hit download here. And it's sending it to my microbit. The microbit hardware is going to become, sometimes on the first download, it sometimes complains. And I can see the dot. Now what's happening is, now my microbit on the physical microbit is running my code, and my simulator microbit is in dongle mode. And the logic here is, whoever starts the last becomes the brain, and all the other ones becomes dongle mode. So why is that cool? Because now it's my physical microbit is running, and it's ignored by simulator. Now, as soon as you make a code change, then you basically have the simulator who's controlling the scenario, and here's the dongle mode. It's a bit tricky. We're definitely looking, if you feel that this is very confusing, we're definitely happy to talk about it. We haven't figured out a better way to handle this fact that we have two brains on the system, because now we really have a connection between the hardware and the simulator. All right, so I can also do the rotary encoder, and here I can have an event when it changes. And for example, what we can do is, what we're going to do? Yeah, we're going to do a forever loop and read the encoder value and put it into the show bar graph. All right, that, and then go back to the encoder. Boom. And now that means when I'm turning my encoder, you can see that it's controlling my screen. And that's all nice. Now, one thing that's happening is you're in a classroom. So this is the scenario where you have hardware. Now, what happens when you don't have hardware? So it means it's all gone, table's empty, you have no Jacdac. I've disconnected it. So there's no more hardware, and sniff, there's no more simulators here. Look here, no more. But this is where the simulators are key, because what you can do is you can go and select them and say, oh, I want a button. Or you can take the shortcut and click on this button here that says, just give me all the simulators that MakeCode needs. And it spins up a rotary encoder for you and a button. And in fact, if you see the names here match the names here. And we call that the role. That means we've bound the simulator to this variable here. How am I doing with time? And if I move that, then I can actually test my code. So you can do a lot of the Jacdac development without any hardware. In fact, we provide simulators for all the services that we've specified, whether it's a button like here. So let's get the forever out. Whether it's a button, whether it's a slider, we have, if you think about the soil moisture, we have screens. There's a lot of cool stuff there. If there are services missing, we can add them. There's a new infrastructure that makes it much easier to roll out new simulators and new experiences. All right, so this means that when you're developing with MakeCode and with Jacdac, you can do all your work without hardware, and you can simulate everything. And this is huge. That means, if you're bringing in a temperature sensor, this is always my favorite example, and you're measuring temperature and it's outside. I'm going to add the blocks. Yep, thank you for the blocks. Do that. And here I'm gonna grab the temperature here. I'm just gonna chart it just like the other time I did, and this kind of classic way to show data. Actually, let's do something else. What we're gonna do is a little event here. All right, so we're using the thermometer, and I'm gonna ask Jacdac to start my simulator. Now I'm wondering, what's going on with my temperature sensor? And you can see that we've got the console coming in. So what we also do is we send sensor data into the MakeCode console. So now you're seeing, you can chart sensors and data. In fact, if you're connecting a physical device, so I'm going to connect go back and here so I've connected my soil moisture sensor, and I'm going to connect my, something's going on. It is definitely unhappy. Dongle mode, come on. My demo's having issues because my simulator here is not happy at all. All right, we're gonna reload it. Okay. Maybe I need to download my program. Oh, there we go. All right, so I got my data here, and now I can see that. Oh, where's my physical data? Oh. Is this? No, the simulator is gone. All right, so that seems to have a little issues, but normally you should be able to look at the hardware data. So we also want to integrate the data exploration of what's happening in your sensors inside of MakeCode. All right, I'm gonna I'm going to pause that demo now, and I'm going to go to P5JS. So what's going on with P5JS? It's a cool environment where you can, let me go and unload this. I need to make sure the MakeCode editor is not locking the USB device. And this is P5JS. It's a creative environment for JavaScript. And in this case, what we're doing is we're grabbing the sensors. This runs in a loop. Draw runs in a loop. We're exporting RGB as numbers from 3 potentiometer, and then we're setting the background of the screen. And 5 minutes left. All right. I'm going to go and hopefully my little microbit wants to connect again. Somebody's locking the microbit. Somebody's locking the microbit. It's a problem with all these pages that are using the microbit. One of them is locking it. All right. See if we can get it to work. Otherwise, we'll have to. Oh, well, it seems that my demo gods are against me. But normally, you should be able to run the P5JS demo, and this typically doesn't go so bad because you don't have 5 pages trying to connect to the microbit. All right, I'm going to come back to the slides. I have 5 minutes left, and I'm going to talk about where we're at with the roadmap. What you saw that we have MakeCode. We ran a Make Accessible pilot inside of Microsoft. James Devine talked about it yesterday. So we did a big test. We have MakeCode, beta, JavaScript, Python support out there. We've open sourced the software, the firmware, the hardware. If you're a hardware manufacturer, all the Altium, KiCad, Eagle stuff is out there. Our goal is to get the MakeCode integration stable and ready by the next big release, typically around June. We want to start piloting with teachers ASAP. If you're not yet applied to the champions, try to get registered. If you're a manufacturer, make sure to send us an email at Jacdac at Microsoft. We want to talk to you and see how we can help you integrate Jacdac into your devices. Manufacturer slide. Let me hide that. What do we have? We have a DDK, a device development kit, which has schematics for you. We have a large library service classes. We have firmware for STMs and other popular MCUs. We've got all the web-based debugging and tools. What you have to do is, if you want to use Jacdac, integrate the connector into your hardware. Use our drivers software, or use your own. Validate that it works with the dashboard, and you're good to go. Talking about how to migrate your modules, typically Jacdac can be single purpose modules like we've seen in my demo. These are all like kind of, there's one a slider is just a slider, but there's also a huge ecosystem of accessories out there. And what you could do is add Jacdac to your accessory. We use pin 12 on the microbit, which is a pin nobody's using. So you could connect Jacdac to do pin 12, add the USB connector and the circuitry that's needed. And then basically you would have an extensible accessory for Jacdac. What you can also see is that the device we have here, the Jacdapter, is not passed through, but you could have a different design here that actually exposes the edge connector as well, so that you would have both Jacdac and regular Jacdac integration. Since Jacdac only uses pin 12, it is compatible with all other shields out there. And this concludes this Jacdac presentation because I am running out of time. Yes, this is the last time. And 1 minute left. Thank you so much for attending. If you're a champion alumni, please send us an email at Jacdac as well if you're interested. We really want to pilot it. We're looking for your feedback, especially around the MakeCode integration. And again, this is all live as far as the software. You can try it out. The only problem is we need to get hardware out, but that's going to come soon. And that's it. I'm done, Corinne.
Oh, Peli, this was unbelievable. We're just seriously, this rocked. So thank you very much, Peli. I know at Fair Chance Learning, we're going to connect with you. We just think you have changed how the classroom all over the world will, become so much more user friendly for students. I love the daisy chain effect. If you would, everyone, please click leave session and return to the session to move on to your next session of awesomeness and have a great rest of your Microbit Live event. Have a great one. Again, Peli, you rock. I'm so glad you're my neighbor. We have to talk.
Bye, everyone, and enjoy the live sessions.
Bye.